So this question says the demand function for a certain brand of compact discs is given by this equation here, where P is the wholesale unit price in dollars and X is the quantity demanded each week, measured in units of 1,000. Compute the elasticity of demand when X equals 4. Okay, so I'm going to just write up here in the left corner everything that I know. So I know that X is equal to 4. Because I know X equals 4, that actually also helps me to figure out what P is equal to. So I'm going to write out my P equation, but I'm going to replace X with 4. So I have P equals negative 5. Instead of X squared, that'll be 4 squared. And then minus 4 times 4 plus 99. 4 squared is 16 times negative 5 is negative 80. So that becomes negative 80. Minus 4 times 4, so that becomes minus 16 and plus 99. Negative 80 minus 16 is negative 96. And negative 96 plus 99 is equal to 3. Okay, so I'm going to erase all that now and just write here that P is equal to 3. Okay, what else do we know? Well, the question asks for the elasticity of demand. So there's a formula that we need to memorize or have in our notes for that. That formula is E of P, which stands for the elasticity of demand. Remember, P is demand. So E of P is equal to negative P times F prime of P, all divided by F of P. Okay, so we have P, right? So we know that this is 3 here. But what we don't have is this F of P, right? So let's figure out, well, how do we find F of P? Well, F of P is always equal to, I'm not sure why I wrote it like that. F of P is equal to X from the demand equation. So I need to take this demand equation, P equals negative 5x squared minus 4x plus 99, and somehow I need to solve for x, because if I can solve for x from that equation, then that is what gets me to my F of P. So let's do that. So I can see, let's see, I have negative 5x squared minus 4x plus 99. I am actually, there's no way that I can see at least for how to factor this right away. Right? So if I think about having two sets of parentheses, and I think about like having a negative 5x here, which I don't like to have, and then thinking about, well, what could go here and here so that I have multiples that multiply up to 99 and then add up to negative 4. I don't think there is anything. 99 has multiples that are 3 and 33, 9 and 11, and basically 1 and 99. So if I started to place, and I'll use a different color here, if I started to place some of those numbers in my parentheses here, I don't think any of them are going to work out, but let's try it. So if I put a 33 here and a 3, I'd have negative. So once I've multiplied this out, there's no way that's going to get me a 4, so that's not going to work. If I put my 33 on this side and my 3 on that side, that's 15 and 33. No way to get a 4 from that either, so that's not going to work. And if I use 9 and 11, so I use a 9 here and 11 here, that's 45 and 11. No way to get 4. Right? So my goal is to get a negative 4, by the way. So there's no way to get a 4 from combining those two things together. And if I put 11, if I put 9 here and 11 here, that's 55 and 9, so there's no way to get 4 from that. And definitely no way to get a 4 if I put 99 in there. That's just way too big. So here's what we're going to do. And this is probably the hardest part of the question, is knowing to do this next step that I'm going to use. Because I still need to get x by itself. I still need to isolate x. The problem is that I have an x squared and an x right now. So I have two different types of x's. How do I get rid of that? The only real way to get rid of that is if I complete the square. So completing the square is a process for factoring a trinomial when you can't really do, where you can't factor it in any other way, basically. The first step to completing the square, so I won't write out the steps, I'll just do them, but it might be good for you to write the steps out as I do them. The first step here is I'm going to remove this 99 to the other side. So now I have p minus 99 equals negative 5x squared minus 4x. Next, I'm going to divide everything by negative 5. Why am I going to do that? Because when I complete the square, I want my first term to just be a positive x squared, nothing else. So I'm going to divide everything by negative 5. By dividing the left-hand side by negative 5, in fact, I won't do that yet. I'll leave it as is. So p minus 99 divided by negative 5 equals, now this is gone, so it's just x squared. And negative 4 divided by negative 5 is a positive 4/5 x. Okay, so this is our goal with completing the square. I just want to have a positive x squared and then my x term. The next thing I'm going to do is take half of this term, right? So it'd be 4/5 times 1/2, which is 4/10. 4/10, however, reduces to 2/5. Right, so I'm going to just reduce it. And then, after taking half of that middle term, I'm going to square it. So 2/5 to the second power, which is going to be 4/25. Because 2 squared is 4, and 5 squared is 25. And then I'm going to add that number to the right here. And you'll see why all of this is super helpful in a second. Now, the issue is I just added 4/25, which was not there initially, which means I have to also add it to the left-hand side of my equation. So let's just erase this for space. And I'm going to, for now, just put over here plus 4/25. We'll clean that up in a second. So what was the point of adding that 4/25? Why is this called completing the square? Well, because now I can take this trinomial, this x squared plus 4/5 x plus 4/25, and I can neatly put it into parentheses as x plus 2/5 to the second power. That 2/5, by the way, is the half of this 4/5, right? So if you remember before I erased it, half of 4/5 reduced to 2/5. Anytime you're completing the square, you will always have, like this number here will always be half of this middle term here. So this is useful because now, as you can see, I only have one x. I only have one x here. There's no x squared and x. It's just an x there. And you'll see how I get it out in a second. So on the left-hand side now, I have 4/25, right? Because it's a positive 4/25. In fact, before I do that, I'm gonna deal with this p minus 99 over negative 5. I don't want to divide by negative 5. I just think it's a bit clunky to have it there. So instead, I'm going to multiply. I'm going to take this negative from down here and apply it up to the top here, which would make this a negative p plus 99 over a positive 5. But I actually prefer to write it differently. It'll still be the same, but I'm going to write it a little bit differently. And that is 99 minus p over positive 5. Hopefully you can see that this is the same as that. It's just moving that negative sign elsewhere where I don't have like a negative denominator. I think that's a bit weird. So that's why I did that. Probably don't have to do it, but I think usually when there's a negative in the denominator, it just causes issues later on that you want to avoid. So I'm avoiding it. And then, of course, I can't forget that I added 4/25 over here as well. Okay. All right, so now what? Well, now I can take the square root of both sides of this equation. And my right-hand side, let's just go up here for more space. My left-hand side is the square root of 99 minus p over 5 plus 4 over 25. And this is going to be equal to just x plus 2/5. And hopefully you start to see that this is why we did all that work, right? Because now I only have an x. So it becomes very simple to just subtract 2/5 from both sides and isolate x and get x alone. So I'll have here just x equals the square root of 99 minus p all over 5 plus 4 over 25. Again, that's all still under the square root. But then my minus 2 over 5 is not under the square root. Okay. So now that I have that, I can go back up here and remember that x is the same as f of p. So I'm going to just write this as f of p. So f of p equals, I'm going to write this as a parentheses and fraction exponent form. I'll explain why in a second. 99 minus p over 5 plus 4 over 25, close parentheses, 1/2 power, and then minus 2/5. Okay, so why did I do it that way? Why did I convert it from square root to 1/2 power? Well, it's because now I need to find f prime of p. Right, like that's the only thing that I'm missing. Again, we already know p is 3, so we have that. I just figured out what f of p is. It's this long equation there, but I still need to know what f prime of p is, right? So in order to find the derivative, I'd rather have a fraction exponent than having a radical or a square root, because having that fraction exponent allows me to just use the power rule when I differentiate this, bringing that 1/2 to the front, keeping my 99 minus p over 5 plus 4 over 25 to the negative 1/2 power now, because I subtract 1 when we use power rule. I have to now multiply by the derivative of the inside of the parentheses. That's what the chain rule is all about. The derivative of 4 over 25 is 0, so I don't have to worry about that. The derivative of 99 minus p over 5, let's just do that in the corner over here. So if I have 99 minus p over 5, obviously I have a fraction, so I will use the quotient rule. To find the derivative, it's low, so 5, times d high, or derivative of the numerator. The derivative of the numerator is just negative 1, because there's no derivative of 99, and the derivative of negative p is just negative 1. And then I subtract the numerator, which is 99 minus p, times the derivative of the denominator, which, again, the derivative of any constant, like 5, what we have here, the derivative of 5 is just 0. So that means this whole thing goes to 0. And then I divide by the denominator squared, which is 25. And just for review purposes, all I've done is the quotient rule, which again is b low, d high, so b times a prime minus a times b prime all over b squared. That's all I've done. So we have a negative 5 over 25 here. Let's get it multiplied by this. So it becomes negative 5 over 25. But negative 5 over 25 can be reduced to negative 1 over 5, because 5 goes into 5 once, 5 goes into 25 5 times. So really this is a negative 1/5. So I'm going to just take care of that now. Negative 1/5. Okay. And then there's no derivative for this negative 2/5 here. It's just 0 for the derivative portion at least. So let's get rid of this completing the square. Really, let's get rid of all of this stuff, because all of that just helped us to get to everything that we need in order to answer the question. And now we can answer the question, right? So as much work as that took, we're about halfway finished right now. Okay. So again, the question wants us to find the elasticity of demand when x equals 4. And again, that equation for elasticity of demand is E of P equals negative P times F prime of P divided by F of P. So negative P is -3, right? So we're at the stage where we can start plugging things in. So I have -3 for negative p, right? Because again, p was 3. And then f prime of p is this. Now, I can actually simplify this further because I have a -1/5 and I have a +1/2, which makes that a -1/10 when I multiply them together. And of course, I'd still have my 99 minus p divided by 5 plus 4 over 25, close parentheses, to the -1/2 power there. So when I multiply this by my f prime of p, that's what I'm going to multiply by. So this gets bracket -1/10 parentheses 99 minus p over 5 plus 4 over 25 to the -1/2 power. And then we're dividing all of that by f of p, which is just 99 minus p over 5 plus 4 over 25 to the +1/2 power and -2/5. Okay. All right, so how do I simplify this further? Well, I have this -3 times -1/10. So I'd have a 3/10 here. 99 minus p over 5 plus 4 25ths to the -1/2. And I still have this 99 minus p over 5 plus 4 25ths to the +1/2 -2/5. Okay, so what's left? Well, I still have p involved. I know p is equal to 3, so I can start plugging that in. So I can plug in a 3 here for p. I can plug in a 3 here for p. And that's pretty much it. So let's do that. Let's go this way. So I still have my 3/10. But now 99, so I'm dealing with this first. 99 minus 3 is 96. So I have 96 over 5. Plus 4 over 25 to the -1/2. And on the bottom, I'd also have 96 over 5 plus 4 over 25 to the +1/2, but then -2/5. Okay. So I have a lot of more math to do basically. If you're using a calculator, you can probably plug a lot of this in and start getting some real values. The tricky thing is that the calculator might give you decimal values, but that's okay if it does. I'm not going to do it that way, but just letting you know at this stage, you could really put this entire thing into a calculator and see what the output is. But I'll show you the longer way to get it, how to get the fraction answer out of this. So from here, in order to combine these two fractions, I have to have a common denominator. That common denominator will be 25. So I need to multiply 96 by 5, which is 480. So then I have 3/10, and then I'd have 480 over 25 plus 4 over 25 to the -1/2. And the same thing on the bottom. I'd have 480 over 25 plus 4 over 25 to the +1/2 minus 2 over 5. Let's keep going. 480 plus 4 over 25, well, that's going to be 484 over 25 to the -1/2. And then here, I'm going to have the same thing, 484 over 25 to the +1/2 minus 2/5. Okay. All right, so let's see. In my calculator, 484 does not divide by 25, but if I were to take that to the 1/2 power, I can reduce it. So for instance, 484 to the 1/2 power, which is the same as taking the square root of 484, is 22. This becomes 3/10 22. The square root of 25 is 5, so 22 over 5 to the -1. Why is it -1 now? It's because I already square rooted. So I took care of the 1/2 part, but it's still negative, right? So that stays as is. On the bottom, it's going to be the same thing. 484 over 25 to the 1/2 power is 22 over 5, but I still have a -2 over 5 down here. So I can combine my denominator. 22 over 5 minus 2 over 5 is 20 over 5. And I still have 3/10 here. And then 22 over 5 to the negative first power actually just makes the reciprocal, making it 5 over 22. Okay. And let's reduce some things. So 5 goes into 5 once. 5 goes into 10 twice. So I'd have here 3 over 44. And then down here, 20 divided by 5 is 4. Right? So right now I have 3 over 44 divided by 4. So let's just do that horizontally. 3 divided by 44 divided by 4, let's call it 4 over 1, is the same as 3 over 44 times 1 over 4, which is equal to 3 over 176. And there's our answer, 3 over 176. Okay. Now, again, how could you have answered this question in a much shorter fashion? Well, first of all, it wouldn't take as long as this video is because I'm explaining everything step by step. But at this stage right here, either here or even here, you could throw this into a calculator, like just put this entire thing into a calculator. It would give you a decimal, and then you'd have to go back and check what's the decimal equivalent for each of these things. And then the idea is that answer choice B, or the second option here, would have an equivalent decimal version of what the calculator spit out when you plugged it all in here. So hopefully this is very detailed enough for you to see the process. I'll go over one time really quickly again. The question gave us the x value. We used that x value to find a p-value. The question asks for elasticity of demand, so we know it's that formula. We have to then realize that f of p, which is very important for the elasticity of demand formula, is equal to the x in the demand formula, which means we have to take this demand formula and solve for x. That's what took a lot of time initially, where we used completing the square in order to get our x value. And then from that gives us our f of p. And from there, we take the derivative of f of p to get here, and then we take all those bits and plug it back into the actual elasticity of demand formula that we're using in the first place, right? So we plug everything, plug the p in, we plug the f of p in, plug the f prime of p in to that, and then it's a lot of math, a lot of algebra, simplifying everything. So let me just see, I think maybe, yeah, for sure, it's at this stage where you can plug things in, right? Because everything else prior to that stage still had a p involved. So you could have plugged in 3 sooner, right? I definitely could have done that, but I'm trying to show every step. So again, it made things take a bit longer. But you could have taken the very first stage of this, plugged 3 in for p, and then put that straight to your calculator to get a decimal or fraction, if your calculator will turn that into a fraction for you.